Welcome to Industrial Problem Solving. My name is Dave Roysum. I am super excited to continue our new mini-series on web inspection. Here we will give you many tips to improve web inspection at your suppliers, and in your plant, and at your customer's plant. I know your time is precious, so let's get started. Now would be a great time to see where we've been and where we are going. In the last mini-series, Web40122d through G, we discussed in great detail the traceability of web products from your supplier to your customer and everywhere in between. In earlier clips in this mini-series, we showed best practices for web inspection on your machine and or in your test lab by constructing simple light booths. Please see these earlier clips if you've not already done so, because we will be building on what we learned earlier. In this clip, we will show what to do in the likely event that you don't have a good inspection station on your machine, or in your test lab, or if you are at your customer and they are not so well equipped. In the next clip, we will finish this series with a brief introduction to wound roll inspection. We only need a few resources to do some decent detective work. That includes a broom, a very flat floor, and a bright flashlight. With these minimal resources, we can check for bagginess and some other flatness problems. With these minimal resources, we can check for many, if not most, visual defects. As with most any inspection, we first peel off the outer layers of the wound roll. Then we want to pay out 10 to 50 feet of material. There is at least two ways to do that. One is to use a shaft through the core. Another way is to unwind the roll by rolling it on the floor, though this method can sometimes mark and damage the outer layers. Which is best depends greatly on the type of web you have, as well as the geometry of the roll. Next, we will flatten the web as best as possible on the floor. One method to do this I call the fluff and pull method. Another is to use a broom to sweep down the web and slightly outward from the center in alternating directions. As we described in clip 401.22c, side lighting will greatly help bring out flatness issues. However, you will need to play with your flashlight a bit to see what position works best. Your viewing position should be very low, possibly even lying on the floor. You should mark the CD position and the width of either the tight lanes or the loose lanes, whichever makes sense for the problem you have. In this figure, we have marked the two tight lanes that are the defect rather than the three baggy lanes that resulted from the tight lanes. You should also consider measuring the severity of bagginess, perhaps using the strip test. For narrower webs, camber or bow will be easier to measure, though this is a pretty imperfect test. See my Baggy Web series, Web 201.45a through R, as well as its playlist for further information on troubleshooting and fixing bagginess and similar flatness issues. The most common reason to lay a web out on the floor is to inspect for visual defects. Lighting is not so fussy other than it should be without shadows. Once you have trained your eyes to spot the defects, circle every single one with a marking pen. As an optional best practice, measure the X and Y locations of every defect for reasons that we will give in the next slides. You have probably heard how great the human brain is in recognizing certain patterns, such as faces. We may each be able to recognize hundreds, if not thousands, of family, friends, coworkers, and acquaintances in less than a second, even if we do not know or remember their names. Yet, the human brain can be too good at trying to recognize patterns, such as when they don't even exist. One example is seeing patterns in clouds, though there are many others. This miswiring of the human brain is called pareidolia. On the other hand, some patterns are almost impossible for us to see even when they are there. In those cases, we may need statistical help to see patterns or to check if those patterns are really there. So here are 3 different defects: some yellow suns, a blue cloud, and a few red lightning bolts. Are there any patterns with any of these, or are they random? Pause the playback and study the figure. Time's up. So, what did you conclude? Well, most of us would have noticed that the suns and lightning bolts occurred in lanes. This streaky behavior is quite common with web manufacturing and web converting processes. However, you should have been much less confident about the single cloud, as not much can be said with only a sample size of 1. What is most important here is that there are very important MD patterns in these defects that our minds would seldom be able to see. That is, when the defect is at the onset of being fully developed. That is, in fact, the most common case, at least early on. So, the yellow suns were caused by an element that has circumference C1, and the red lightning bolts were caused by an element with circumference C2. Our mind simply could not fill in the missing pieces when the system is at the onset of being fully developed. The great news is that fast Fourier transform analysis, which can be done in either a statistical program or even just a Microsoft Excel spreadsheet, would have no difficulty seeing the pattern. Even simpler yet is that you might have noticed that the MD spacing is an integral number times the circumference. Thank you so very much for joining me in this problem solving and problem preventing series that is based on web and role inspection. Here we have given you several best practices and tools for looking at your webs, ranging from simple observation to advanced FFT analysis. Stay tuned for the next clip where we will talk about wound role inspection, one of my favorite topics. If you found anything interesting or useful here, please like and share. Also, please consider supporting the work of this channel using the Patreon link below. Patreons are given special thank you gifts ranging from email help to a signed copy of my latest book, the must-have 500-page Web Handling Handbook. See you next time.